So, same directions as day one, but now there's the equal sign. Makes a difference. Your goal is to get the bases on both sides the same. Well, on the right side, the base is 2. Can you change that base a whole lot? You could try, but might as well leave it as 2. Well, hopefully then on the left side you could do the same thing. Can I get 64 and rewrite it somehow so that it's base 2? 2 to the 6. Now here's the important part. Seeing these are the same. When we simplified, whether we were multiplying or dividing, we just wrote it down, right? Well here, let's face it, that better say 6 when this thing's done, right? Or this has no chance of working, right? So when you're solving, once you get the bases the same, really they don't have any more bearing on the problem. That 3n plus 1 better equal 6 or this isn't going to work, right? Now if the bases aren't the same, well then you still have some problems. But basically once you get them the same, you can just cross them off and don't even worry about them anymore. What we did is we took the variable from the exponent and we were allowed to get it out of the exponent in a way because we don't need the base anymore. Okay? And so now you just solve as if it was any algebra that you've ever done. So 5 equals 3n, divide by 3, n is 5/3. Now I can't imagine too many of you were looking at that, oh, 5/3. Now some of you maybe. But, you know, guess and check gets a little bit more difficult. So, told you get the bases the same. Well, this 3, is there a whole lot I'm going to be able to do with that? I mean, you could make it a 9 if you really felt like it, but then that's more work. So it's 3 to the 4th equals, well, let's make that a 3. And it's 3 to the 3rd. Now, here's the part many people will mess up on. Notice how I wrote it. Some of you may only put the 3 times the m, and if you do that, you will get it wrong. See how I put m minus 1, I have to multiply. But the bases are the same. So basically that better say what for this problem to work out? Better end up equaling 4. Do I care about the 3 anymore? Not this bottom one. No, I don't need that anymore. So 4 equals, well, now we can distribute. What does it have to equal? 3m minus 3, right? So plus 3. 7 equals 3m. Divide by 3. M is 7/3. It's not always divided by 3, just so you know. Any questions so far? They don't really get a whole lot more difficult. They just look different, like these two. And here's where creativity is helpful. In Chapter 5 of Algebra 2. Well, let's try and get these bases the same if at all possible. We've got a 16 and a 32 that's in the denominator. That's not very helpful. Well, let's just look at those numbers in general and see if we can get to the same base. And no, don't tell me that 16 squared is 32. All right? But we can get to a base of 2, right? So let's do that. This is 2 to the 4th. But remember, yeah, you got to type it times all of that, right? Don't forget that. Equals, so this is 1 over 2 to the 5th. Well, that looks quite a bit different from what we just had in the last problem, doesn't it? That 2 to the 5th is very much not helpful where it's at right now. Where would it be much more helpful if it was in the numerator? So, make it unhappy. Exactly. Put it there. I don't care if the 2 is happy or not. I need to solve this problem. All right? So what you're going to do is you are going to make it unhappy. You are going to put it on the numerator. But once you make it unhappy, what signifies that it is unhappy? Yeah, -5, right? Just imagine being some student coming in here and not having it taught that way to them. They'll have no clue what I'd be talking about. But now that the bases are the same and they're all on the same level, now all I know is that whenever this gets all said and done, it better be -5. Or this has no shot of actually working. And so the 2, again, that base has become not important. Well, should I distribute right away? All right. So what do we got there? 8n plus 4. I almost wrote 8. Good thing somebody said that. Equals -5. Minus 4. 8n equals Negative 9 divided by 8. And equals negative 9, 8. Okay. Any questions on any of those so far? Well, don't we kind of have the same problem with the next? Well, what base are we going to go for? 5, right? So the right side's set. How are we going to fix this other side? Because it's really 1 over 5 squared, right? Well, that's not very, yeah, just make it unhappy again, right? So put this, okay, that works too. In fact, better, I might just do it that way all the time. 5 and then negative 2. Wow, well, there we go. I fixed it. It just looks really silly. So this is 5 to what? Ooh, we haven't done this in a little while, about 10 minutes. Negative 4n. Now, I think this is the first time there was a variable on both sides, though, right? When we got done. But whatever n value I put on this side and whatever n value I put on that side, they have to be the same if I'm going to take 5 to that power and have them be equal, right? And so 5, no longer important. Negative 4n equals n minus 5. What should I do here? A lot of people mess this up. Yeah, subtract the n over. Very good. Some people try and put the 5 with the 4 and just, yeah, I don't know. It gets messed up. Anyways. So, negative 5n equals negative 5 divided by negative 5. And n equals 1.
Good job.
Okay. Any questions? Nothing? Well, apparently I have another page. Oh, I have one more that you need to add in on the back. Oh, if you have room, yeah. That's fine. Yeah, it was. Yeah, that is kind of small, isn't it? We'll supersize it. And she's a little blurry now, so I don't. Yeah, you can do a letter or number 5 or letter E or yeah, whatever. Okay. Yeah, number E, sure, that works too. Everybody's good? Well, obviously, I think there's a huge got it? Okay. It's not that it's unhappy this time, it's just there's a radical on it. But if you look at the 3, can you see how you can possibly get the right side to at least a 3? I don't think we want to try and get the right side to a square root of 3. You could, but I don't think that's how you want to attack this one. So let's just rewrite this as 3 to whatever it is. And it's 3 to the 4th. Very good. Any ideas on how to get that actually to have 3 as a base instead of square root of 3? Well, we could square, but that's kind of weird with exponents. Because then we have to square the other side, and it gets kind of iffy. But you can rewrite it. Close. 1/2 power. Remember what we did on the other notes? Is hopefully you agree that 3 to the 1/2, that's a 2, is equal to a 3 here with a 1 and a 2, right? Same thing, and isn't that what I have, a square root of 3? So you write it as 3 to the 1/2 power, but I have to take it times x plus 1. So now, I hope you're starting to see how helpful that chapter in Algebra 2 can actually be. Okay, without it, if you never would have seen that before, this would just be ridiculous. You'd be like, what are you talking about? Okay. So in other words, this has happened. There's actually something, you have 2 options now. You can distribute the 1/2, but I think there's a better option in this case. not divide by 2. Basically, we could divide by a half, but dividing by a half is the same as multiplying by 2, right? So let's just multiply both sides by 2. Why would I do that? Because what happens here? Yeah, they cancel. Do you have to do it that way? Is it okay to still distribute the half? Yeah, you're going to get the exact same answer. It doesn't matter. So x plus 1 equals 8. X equals 7. Okay, any questions? All right.